Here's an example. This is a diagram version of a plant community, and the species evenness is not very high. We have 4 different species, which is not too bad for 20 individuals, but 17 of them are all this grass here, and then 1 each of 3 different flowers there. The grass is a flowering plant as well, but its flowers aren't as impressive looking. Here we have much higher evenness. We still have the same 4 different species, but there are 5 of each of the 4 species. So the balance between the species is much closer, and same number, so biologists think of this as more diverse. Even though it's got the same number of kinds, the distribution among the types of kinds is more even. Where would you find a community that has lots of species, high species richness? Many different factors influence this. What complexity is there? The more complex and varied a region is, the more possible niches there are, more possible types of things. For example, out in the open ocean, in the middle of the ocean, you got water and more water. Okay, you can swim up and down, but you're still water. Not much variation there. In contrast, if you're at a coral reef, that reef provides all sorts of little nooks and crannies and different places up near the surface, a little further down. A lot of variation in the structure. Similarly, a forest has more structural complexity than a grassland would. Geographic isolation. An island way out in the middle of the ocean typically has somewhat fewer species than an area that is part of a big continent as far as land species go. Because that island way out there, land things have challenge getting there. And so only something happens to reach it, will we see that particular kind there. So more remote islands tend to have fewer types of things. Islands closer to bigger masses of land tend to see more. Are there stresses on the habitat? This could be artificial, human caused, like pollution, or natural, say a desert with the extreme temperatures. That's going to limit the types of things that can live there. Or a salty spring. What likes the salt? You've got limits there. Where you are in the globe. Are you near the poles? Colder areas tend to have less diversity. The warm tropical areas tend to have the most. One suggestion is that it relates to the amount of energy getting from the sun. It goes along with being warm all the time. That extra energy contributing. That's certainly a factor. Another issue is how stable these are. There are multiple factors that may play into that. What other communities do you have around? If you're close to the edge between one community and another, you can start to get some things that are more part of another community kind of coming in there. And so you often see diversity near an edge. Do we have some dominant species that just takes over and nothing else is able to do very well? Like kudzu totally covering something, shading out the other plants, and you got a big mass of kudzu and not a whole lot else. Not great diversity. What sort of disturbances are there? No surprise, if you've got too much disturbance, that tends to not be good for a lot of things. On the other hand, if things totally do not change, then you get more chance for something to be dominant and take over and outcompete other things. While if it's stirred up a little bit, that helps keep that from happening. So there's debate as to kind of what level of disturbance is going to give you the greatest species richness. This particular graph relates to the island isolation pattern. As islands get further out, the number of species is generally declining. Stability relates to the number of species as well. If you have lots of different species, and one of those got a problem, there's other things that's probably not going to have as big an impact on the whole. Now, okay, you do have keystone species, but probably a little less effect there. But anything that disrupts not just one species, but a whole category within an ecosystem, that's going to have much more devastation. And then trying to recover back to a more complex setting may be more difficult. So there are different factors in here on the species richness. More species may be resilient up to a point, but when things get too bad, they may tend to more completely crash. One commonly observed pattern of change, especially thanks to human activity, is succession. This is the change over time in communities under a given situation. We tend to focus on plants. For one thing, plants do a good job of holding still. So it's not too hard to go and see what types of plants are in an area. They don't fly away. And somebody else can come along next week and still find the same plants. It's a relatively consistent thing. And there are some good patterns that we see in plants. Also, what plants there are, well, it has a big effect on what the animals can do. So it's not totally avoiding other species, it's relevant for them as well. So succession is what we think when there's been some sort of disturbance. How do things change over time, maybe eventually reaching back to where things were before the disturbance. We can think of primary succession, where an area has been totally cleared of stuff living there. Say a volcano erupted, or a glacier came along and totally wiped out things, or maybe people had totally cleared the area to build something and then it's recovering, things like that. Secondary succession is when, okay, just vegetation's been removed, but it's not totally wiped out. This could potentially happen naturally, say with a fire, or humans coming in, say cutting down a forest, mowing a field, things of that sort. And so over time, let's say we have an area, goes through succession, and around here, a typical pattern would be going from a grassy field to having taller grasses, other soft plants growing there. And then we start to get some young trees, some saplings growing up. Typically the pines are the fastest ones here. So we start to get pines growing in our old field. And if that keeps going long enough, we start to get the slower growing hardwoods as well. Eventually we have taller pine trees and hardwoods growing up in there. And as the hardwood gets big, they tend to shade out the pines, and we eventually end up with a hardwood forest similar to what the vegetation would normally be around here if it weren't for human disturbances. But even if we had some place where people aren't doing anything, there's going to be various natural disturbances happening. Start out with a nurse log. Tree falls over. Now there's a gap in the forest, plus anything gets knocked over. And now we'll start to have the succession go through in that patch opened up by the tree falling. Or maybe there's a storm that comes through. Or some types of animals may be able to take out some of the plants, a fire, a variety of things. But mature communities tend to be more stable, and that gives more opportunity for specialization. So you can have more variety and different environmental gradients. Here's a little sunnier, here's a little shadier, here's a little wetter, here's a little drier. This is more steeply sloped, this is flatter. All those types of variations will tend to lead to slightly different things growing different places, and we get this variation. This leads to the suggestion that having a somewhat intermediate level of disturbance is best for species remnants. Enough to prevent any one thing from taking over, but not so bad that only a few things can manage in response to it. So, there's some variation here. I mean, you can think of this, say, again, our field succession, a lawn. If you're mowing it regularly, keeping it really short, not too many plants are going to be happy with that. You're only going to get a relatively limited number of things that can tolerate that very high level of disturbance. But if you've cut down the vegetation area and then leave it alone for several years before trimming things, you're going to get a lot more different types of plants and the associated animals in that setting than in a lawn that's mowed weekly, say. On the other hand, if things are not disturbed at all, you can potentially get stuff that does well in those stable conditions to dominate, and the other species, the things that are more characteristic of earlier stages of succession, will be quite rare or absent. On the other hand, if there's not much disturbance, then you can specialize more into particular niches, more partitioning of a habitat. So things go both ways. Part of it depends, what's the natural pattern? An area that naturally has disturbance somewhat regularly, well, things will be adapted to that and deal with it. For example, I mentioned the longleaf pines and the sandhills, areas that naturally would have lightning starting fires fairly often, and if those areas are allowed to burn, then some types of plants can't take over, and you get more diversity, closer to the what would be natural without people involved. If you block the fire, certain things can take over and dominate. But if you have something that tends to be very stable long term, say tropical rainforest area where the climate stays about the same year round, things very much specialized for that very constant condition, and you have high diversity with relatively low disturbance. So it does depend on your situation.